All right, so we're on. So I think we'll probably get started around like 6:05 to give people some time to join. So far, we have 7 people who are waiting for the event to get started. I think I can probably actually just.
Yeah, I see your presentation come up.
Okay. Yeah, so yeah, it's like a 5-second delay. I wasn't sure if it actually was displaying right now. I feel like I should have like elevator music or something. It's a little bit more than I thought it was. Okay.
Seems there are 12 people now. That's a
yeah. The numbers going up. I think we had about 20 people the last time, and considering we had less time to advertise than usual, I thought that was actually a pretty good number. Plus, we also advertised your event at the last meeting, so no pressure. someone else. How are you all feeling? Do you want to get started or do you want to wait a couple more minutes?
I see someone commenting on the meetup saying that they're seeing the YouTube link but no slides.
They don't see it. Okay, hold on a second. Yeah, they should be seeing slides because that's the only thing we have right now.
Yeah, I'm able to see it as well, Cynthia.
Okay.
I'm on the YouTube channel.
All right. Yeah. So this is so I will. Don't worry. I'll switch over to you all once we get through these. So I guess with that being said, are you all ready to get started?
Yep, sure.
Okay. Well, hello, greater internets, aka dcast. Thank you all so much for coming with us, joining us for our presentation by FINRA on how to process billions of events. Before we get started, we just wanted to do a service announcement for dcast. So dcast is run by us four lovely people shown here. We have Peter Kim, we have Jean Gadamer, we have myself, Cynthia Wu, and we have Jennifer Galvin. And this is our part-time job, so we would appreciate any feedback that you all may have to make sure that we make this as good of a meetup as we can to ensure that everyone gets the most out of the information we provide, and that we're also doing our best to fulfill our mission, which is building a testing community and making sure each of us get enrichment that we're seeking outside of our jobs. So with that being said, so just a little reminder who we are as dcast. We are the largest testing meetup within the DC area. We're always looking for presenters, so if you are interested in terms of how to get involved, you can join us on Meetup. You can also join us on our Slack. Sorry, I actually copied these slides from the last time we presented at STPCon. I don't know if they're coming back, but hopefully they will, and we will join up with them again. Send us an email at organizers@dcast.io if you have any questions. As well, we are also on Twitter, so you can always reach us that way. As well, if anyone has any jobs or opportunities that they're looking to hire at your current company, please feel free to use us as a way to try and find the people that you're looking for. I think we're all sort of searching for, you know, great talents, and the fact that, you're here at this meetup trying to learn something new says that you are someone who other people are probably looking for. So if you have any jobs or openings at your companies, please feel free to use us as a way to try to find, hopefully, your new coworkers. And with that, let's actually get started with our talk today. So with that, I'll hand it over to our lovely folks at FINRA.
Thank you, Cynthia. Hi, let's get started. Hello, everyone. I'm Bharadwaj. I'm the software developer in test and at FINRA, and today with my colleague Uyen, we are gonna go over the load test automation using functional testing and how and the lessons learned using this approach. Uh, the agenda for today's presentation would be we would be going over what are the challenges with the traditional approach of using JMeter scripts, what were these some of the issues we found, what is the new strategy we use to overcome these challenges, how using functional automation helped us as part of the strategy, what is the typical design we follow for using functional automation, and in general running load tests in at FINRA. Then we are going to go a bit deeper into functional automation, JMeter APIs, and what are some common classes and interfaces one can use as part of this. Then Uyen is gonna do a demo of one of our sample JMeter applications, which is built using the functional automation. And lastly, we are gonna go over the whole uh, the whole strategy and how and what are the lessons learned as part of this using functional automation. Uh, so FINRA, or Financial Industry Regulatory Authority, has been authorized by SEC to govern the US securities market. FINRA's mission is market integrity and investor protection. As part of this mission, we every day analyze billions of events and govern govern multiple member firms in order to make sure that they meet the SEC regulations and are compliant. Uh, Taking a sneak peek of what we deal daily at FINRA, FINRA processes around 135 billion market events per day. Uh, we have more than 3,700 security firms, or 19% of the US market, uh, as FINRA members. Every day, FINRA spins up around 50,000 nodes for analyzing these events and running the daily operations. Uh, right now, we manage around 30 petabytes of data. uh, FINRA CAT. CAT, or Consolidated Audit Trail, is a result of SEC Rule 613. Uh, after the As part of this rule, it was require SEC require it requires that all the member exchanges and their families come together to create a consolidated audit trail, which is in order for any US regulator to be able to track the market events from start to the end. To put it into a simple terms, say I purchase a stock for a particular firm, which uh, which is typically done through a brokerage firms. The brokerage firms may be trading in one of the stock exchanges in US. Yes. At the same time, there may be other investors who may be trying to buy the same stock. As part of CAT, it would help. As part of CAT, it would join all the events from buying to selling to the transactions and internal transactions and routing inside the exchanges, so that as a regulator, for every stock or every market transaction, I can get a complete picture of what's happening. Uh, CAT, when fully completed, it would be world's largest database for security transactions for the end-to-end lifecycle. As part of CAT, FINRA, there would FINRA, we have 15 exchanges, 15 US security exchanges providing the data, more than 1,500 firms, and we deal with around 400 billion events every day. So, starting with the challenges we face with the traditional approaches with the load testing. One of the common questions when we start with load testing is, when should we start load testing? Should we start load testing after the functionality is completed? Should we wait till the functional testing is completed and we get a go ahead that the all the feature is completed? Uh, Usually, given the timelines and the SDLC lifecycle, it's quite risky to wait till the whole functionality is complete to start load testing. If someone wants to, if we don't want to wait till the end that the functionality is complete, then we can do component-based load testing for each individual components. Component-based load testing also comes with different challenges of, are we truly testing the whole system for its load, or are we trying to test a particular component or a resource or an application? Another challenge we faced uh, as part of the traditional at FINRA is, how do we determine the load profile? Uh, At FINRA, we divide the applications into multiple categories involving browser-based applications or APIs, which require the responses to be pretty quick, as in the terms of seconds or milliseconds. There are some applications like batch applications or daily jobs, which does not require the responses in few seconds, but rather in the in say like minutes or once a day or like in a couple of hours. Based on these different categories, uh, we look into we look if the application is historical has a history. Say the application is a migrated application or or we already know the historical volume. uh, we use this knowledge of the historical volume to plot a chart and calculate the slope. Based on this calculated slope, we get to the concurrency of the application. This concurrency is used in determining the load profile and determining what the actual number of users or the participants for running the load test. In the, it's not always possible that you have the historical volume. In the scenarios where we don't have the historical volume available, we look into the requirements. Like, does my requirement say that do I need to handle 2 times the volume? Does my requirement say that I need to handle 4 times the baseline? And this calculation is used for determining the load profile. In the scenarios where we don't have the historical volume or the and also the requirements, we go with like we go ahead determining what is the max amount of load our system can handle, or in other words, what is the load after which we see degradation in the performance. As I mentioned earlier, we deal with billions of events as part of CAT and FINRA. So, as part of the data we get at FINRA, we get data files ranging from couple of megabytes to hundreds of gigabytes. When we want to run load tests involving such huge amount of data, it brings up a big challenge of, how do you generate this much amount of data? Uh, and also, as part of a load test, how would you transfer that much amount of data or deal with the network congestion which comes up with this much amount of data? Say like if I want to run generate the node on my local, it's not going to be feasible enough to have, because my network bandwidth is not may not be able to support the amount of load I'm trying to run as part of my load profile. Another interesting challenge we faced as part of FINRA is the lack of plugins as part of JMeter. Uh, uh, at FINRA, we receive data through SFTP or Software Transfer Protocol. which is one of the commonly used protocols to transfer data between organizations and internal systems. JMeter does not have a native plugin to support SFTP. All the third-party plugins which we tried to use either did not have all the methods like using username password authorization or PEM-based authorization, which are commonly used as part of our load test as part of our internal mechanisms in FINRA. Secondly, we were not able to find plugins to directly test the resources on AWS. We were not able uh, to run load tests on common services like SQS or SNS or EC2s, etc. With the advent of microservices and REST APIs, we at FINRA heavily use this internally to talk between the different applications. With the traditional JMeter approach, one is required to have the REST APIs as part of the samplers. The parameterizing the REST APIs and also handling different responses and response conditions becomes cumbersome and difficult to maintain. Even though we have internal SDKs which are used by the applications, this cannot be easily used with the existing JMeter framework. Before I start with the revised strategy, does anyone have any questions on the challenges we discussed? Uh, Sorry for that. So, given the challenges, sorry, if someone's trying to say something.
No, I was gonna say, I don't see any questions right now on the live chat. So if you want to wait maybe 10 more seconds,
Uh,
to see if anyone else
sure,
actually has any more questions.
sure. My bad. I forgot about the delay.
It's okay, no worries.
All right. I'm assuming there are no questions yet.
No questions as of now, so I think you're okay to go ahead.
All right. Thank you, Cynthia. So, given the challenges we've seen with the traditional approaches and in load testing, in starting with the load testing in general, we came up with a different revised strategy for load testing at FINRA. Uh, One of the items we deal with was having a dedicated environment for load testing. Commonly, we generally use like a dev environment or a QA environment for load testing, and these environments are not in sync with the prod environment. So we run into issues with the functionality versus load testing, and also the resources not being exactly similar to what you would expect in prod. To to overcome these challenges, we created a dedicated environment which would be having the resources and the code base and similar to what we would expect in prod. This helped us to run the load tests with tests and analyze the behavior as one would expect in prod. This also helped us in any integrating teams wanting to run the load tests without having to have the conversations and schedule the load tests with all the integration teams involved. We given Given the issues with the getting the data from higher environments and also the privacy and security, we decided to engineer the data as required for the load testing. This helped us with come up with different kind of combinations and also generating the data of different profiles as needed. In order to make the load test easily accessible to all the members of the team and also have dev, QA, and all the members of team the ability to execute the load test, we decided to make the load test automation framework as much parameterized as possible. If we need to run the load test against like two times the load or four times the load, we were able to do this with just a simple changes in the parameters. Additionally, this load test has been integrated to our pipelines or the CI/CD pipelines and Jenkins. This has helped us that anyone can view this load testing framework as a black box without having to understand the full internals and the functioning. Any member of the team is able to run the load test with minimal knowledge. Additionally, we started running the load test on the component based rather than waiting till the whole functionality is completed. This helped us understand and get the understanding of each components better and any performance issues with the load test. Now that we discussed how functional uh, automation as part of the load strategy and what are the challenges with the traditional approach, I want to go over what are the different advantages we saw with using functional automation. The biggest advantage we saw is the amount of uh, effort and the technical depth one needs to spend on the maintenance using the traditional approach. With any changes as part of the requirements or the integration applications is automatically covered and maintained as part of the functional automation suite. As the same functional automation framework is used for the load testing, we did not have to spend more cycles in maintaining the load test automation since it was already up to date. Using the functional automation helped us using create our custom frameworks as required for interacting with the JMeter. We created a different framework to talk with SFTP, to interact with the AWS services, as well as use the internal SDKs to communicate with the integrating applications. This brought down the time required to create the load testing framework from hugely. With using the functional automation, we were able to override and use the internal logging system so that we could have better logs for from the client from the JMeter. Traditionally, JMeter only logs the responses and the requests. You don't get insight into any internals of what's failing or what are the any issues or anything as such. With the custom logs, we were able to go inside the framework to see if there are any part of the frameworks or any part of the integrating applications which is throwing an error, so that we were able to handle the automation and the maintenance of the Lotus scripts much more easier. Additionally, with the object-oriented model, with the functional automation, since with the usage of programming languages like Java, this provides us the load test scripts much easier to maintain, also make it modular and easy to expand and reuse as between different load testing frameworks. So one of JMeter has support to um, different samplers like Bean Shell, Groovies, JS23, as well as Java requests. From our testing, what we found is like Java requests are the fast provide the fastest responses compared to any Bean Shell or Groovy scripts, since they directly run on Java bytecodes and JVMs. This helped us to achieve the considerable amount of throughput than traditional JMeter, Bean Shell scripts, etc. Additionally, since the is um, functional automation takes care of each component and each application, we were able to run the load test on a particular components without having to make a lot of changes. This helped us move the load test automation to earlier part of SDLC, not wait till end of the SDLC. Before I go into load test design, I want to again check if anyone has any questions on the strategy or the advantages of the approach as such.
I'm just checking the chat to see if anyone. I'm also gonna check on meetup really quick. Hopefully no one is posting there.
All right. Cynthia, let me know if I'm good to continue.
So Michael asked, you mentioned there are benefits to leveraging functional frameworks with low tests. I don't know if there's a question yet. Hold on. Oh, what are some of the times to deliver benefits you've seen? So yeah, what are some of the time to delivery benefits that you've seen by leveraging
Uh,
this?
so by leveraging functional automation, some of the benefits we have seen is, uh, as I said, like less maintenance, like having the whole JMX scripts and writing the traditional way of maintaining the scripts has becomes cumbersome as we progress into inside in towards the project. Uh, Additionally, by using functional automation, since we have seen the functional automation always up to speed with the delivery and is maintained up to speed with the with the regression tests and the different pipelines everyone has in place, it's almost always up to speed. So you don't need to have any additional frameworks or additional checks to run your Lotus. One can directly use this one without having to worry about any functional issues or any automation issues as such. Does that answer your question, Mike?
Just give it about 5 seconds to see if he has gotten everything. Okay, so he's replied that it seems like it keeps performance automation in line with functional, which has been a difficulty I've seen in projects past.
Sorry, Cindy, can you reply again? Can
Sure.
you?
So Michael has responded, yes, seems like it keeps performance automation in line with functional, which has been a difficulty I've seen in projects past. So I'm hoping he has he's okay.
Hmm,
But if he
yeah,
does have any follow up, I will. Okay, yes. So if he has any more follow up, then we can answer him later on in the presentation. But it looks like he's okay for now. And
sure.
I don't see any other questions right now.
All right. So this is the high level Lotus design we follow as part of the FINRA. So we have the Lotus running in Jenkins. Uh, this helps us in this has helped us to scale our load test to whatever load profile we want to without having to worry about the resource limits or network limits, network bandwidth, etc. All the load test data and the load test logs are captured in S3, which can be accessed from our Jenkins pipeline. This way, we can switch easily between different environments. As such, also we don't need to worry about load test data or the logs being lost after a Jenkins pipeline is brought down or a server has gone down as such. As part of the load test, our system typically consists of different resources, including a Lambda, DynamoDB, SNS, EMR, SQS, as well as some new AWS services like SFTP Gateway and Athena. All the logs of this application of the systems are logged in AWS in AWS CloudWatch, CloudTrail, as well as Splunk. Having the logs of the system in Splunk has helped us analyze the results as well as go over different integration points or failures as part of the load test. Alright. Uh, since we have gone over the what is the different design and different strategies and the challenges we faced, I want to go a bit deeper into the JMeter API and what are the different and give a high level view of how you can start using Java requests as part of your JMeter scripts. To get started with using Java requests, uh, there are basically four fundamental components you need to be familiar with. Uh, Config test element class is what is used for creating any parameters or maintaining the configurations as part of your JMeter scripts. Config test elements can consist of as simple as something like username password to as complex as cookie managers, LDAP authentication managers, headers, etc. Config test elements provides you with different methods one can use to either retrieve or add default parameters as well as uh, overload the parameters from system variables. It also provides you with the methods that you want to modify the parameters as you go as part of the load test if you want to take the modifications forward. This is especially helpful when you're dealing with something like cookie manager where the cookies needs to be added and modified as you progress according between the load tests as such. Another class which we commonly use is Java sampler context. The sampler context helps you to read the parameters which were configured as part of the test element. One can one can read the parameters as a string, as a long, as different primitive data types in Java. Additionally, you can also uh, access the JMeter variables and JMeter properties, which one sets typically either through JMeter UI or like say system properties or user properties files, etc. This is like a one one point place for handling the parameters when running the load test as such. Sample result implementation helps you load the sample, helps you log the results. As part of sample results, one can say if the load test is a failure or the success, also determine what are the uh, different things you want to load based on if it's a failure or if it's a success. You can also you can also capture nitty gritties like I want to know what's the class name or I want to know the username, which are typically may not be available as part of the responses from JMeter UI. You can capture the response data or the response or the response logs, etc. One word of caution over here is make sure that whatever the results you're capturing as part of responses are small enough so that you can get a peak, but not long enough or large enough that they affect the performance and the throughput of your load test as such. Finally, Java Sampler Client is the is the class which binds all the three elements together. Java Sampler Client is an interface which has many implementations like abstract Java sampler client, which can be extended or implemented as part of your load test classes. It it mainly consists of two methods, run test and setup test. Setup test is used to configure the parameters as well as different environment variables, etc., as part of your load test framework. A run test is typically used to run the test as well as determine if the test has completed or log the results and uh, and also return any sample information as needed. Uh, I would normally recommend you to use the abstract class since it already implements different methods with as part of different methods which are typically needed. If you directly use the Java sampler client, there are a lot of which I usually would care about, uh, which needs to be implemented or overridden. Before uh, before I move further, any questions on the uh, JMeter API or any of the classes we discussed?
Yes, I would wait. I would wait. 15 more seconds for people to type. Okay, so I do not see any questions as of now, so I think you are good to go.
So, as part of a load test, it's not just important like how you run the load test or where it's run or how big the load test you can run. It's also important like how quick or how fast can you analyze the results. So, as part of the analyzing the results, often we ask ourselves like what constitutes a failure for my load test. When can I say that my load test has been a failure? Sometimes, sometimes we can treat like sometimes when you're working with the REST applications, one can say that receiving any 504 or any 502 would be treated as a failure. But when running at a load of millions and billions of events or billions of records, um, we generally treat with a percentage of requests. We say that say like 2% of requests or like say 5% of requests have a failure or not completed, then that would result in a failure. When you are talking into different categories of systems like say daily jobs or batch jobs, you typically don't get a response within seconds or milliseconds. In those scenarios, how do you determine what is a failure? We can look into different systems and see like if a system has and to see that if the producer and the consumer of data uh, are aligned. If we see like there is any discrepancy between the consumer and the producer, usually that constitutes as a failure. Additionally, we look into the requirements to see if you have any requirements regarding when the response needs to be sent. Say if I have a since say for example I have a requirement that a job needs to send me a response every day at 12 p.m. or within 4 hours of when a request has been sent, that's something we determine as a failure of the load test or failure of an application. Additionally, some of the factors you may want to you keep in mind when analyzing the results is the application which I'm looking at is an synchronous application or an asynchronous applications. Meaning, do I expect the response to be as soon as I send a request, or is the application something which works in a batch mode, or something which you need to keep polling in order to get a result back based on what type of applications you're dealing with. uh, the the determining factors for your determining factors for your failure load test results changes. Additionally, the load test is as good and as effective as how easy it is to load the results and analyze the results as such. Hence, it's extremely important that we have a good framework or a good way of logging the failures as well as the application points and the integration points between the load tests. Hence, at FINRA, we heavily use the Splunk and the AWS provided CloudWatch and CloudTrail for logging these results. This has helped us identifying the nitty-gritties between the applications as well as different AWS resources. Additionally, we have built out dashboards around the Splunk results, which has helped us to understand the load profile as well as the different load during the load test through different systems, integration systems, as well as the application. This helped us pinpoint the failures between different databases versus different integration points, as well as different servers as such. Now I want to pass it to Yuin, who is going to go and present do a demo on the load test JMeter and how you can start using the your functional automation.
Hi. Can you see my screen?
Yes, it is coming up,
Uh, okay.
and we can hear you too.
Hi. I'll be doing a quick demo today to show you the JMeter setup and how to run a very small test. Typically, we run the test through Jenkins. With, and we will execute the JMeter test through a shell script. But for the purpose of this demo, I will only show you how to run it through the JMeter user interface. So first I'll show you how to set it up in JMeter. So the functional automation code, we have to build it in a jar and then put it in this folder in the JMeter directory. So it's this jar file.
Hi, Ewan. Could I have you press the hide button in the little toolbar that's
Oh,
in the bottom?
sorry.
No worries.
Um, and in this slide, you see an example of the um, Java request configuration in JMeter. So the class name is the class of the Java sampler client. And then these are the parameters that we could provide in the test. And this is an example of the Java sampler client class. So we define the parameters here, and we could use the parameters in the run test method, and we could execute the code here. And this set response message allows us to write uh, a customized response message that will be logged in the JMeter results. Um, so for the demo, I'll just show a quick test that just submits one file.
Ewan, is it okay if I asked you if you could make it just slightly bigger?
Oh, sorry.
I kind of wish JMeter had already put it into a shortcut key that you can make it bigger. I think it might be under options. I would say just whoop, one more.
Oh,
Excellent. Yes.
is that good?
Yes.
Okay. Um, so here you can see the result. The files were submitted successfully. Um, Usually for a typical test, there would be thousands of files submitted, but for the sake of the demo, I'm just submitting one. Um, are there any questions?
So I do have a question, which is how how is it that you are parameterizing multiple files?
Um, so here we have different thread groups, and each thread group is for um, uh, each one is for a file with a different number of records. So we could provide the number of threads here with um, uh, and we could provide the volume here, which is this parameter. And these parameters are passed through the user-defined variables. So, for example, this one, when it has this format, it means we could pass parameters through the um, shell argument. Did that answer the question?
Yes, so I am going to let's wait for like 15 seconds to see if anyone else has any questions from the live chat, since there is a little bit of a delay.
Sure, so to add it to what Ewan said, we as part of the determining the load profile, we came up with the different samples of data or different samples of sizes which we can use for running our load test, which we have been commonly seeing as part of the different loads we are seeing in the higher environments. Based on that, we have run we have a test JMX files created and to create the X amount of data files. And based on that and the parameters passed through environment variables and JMeters, we are able to regulate and run the load test as required as for different file sizes as such.
So I have another follow-up question, which is like when you run these tests, like so they run as part of your pipeline, yes? Or do you like like I guess like do you have this set up so it runs as part of your pipeline if you're using Jenkins, right? Correct?
Yes.
Yes, it's run in Jenkins.
Yeah. So as I showed up in the high level design, we have a Jenkins pipeline where we can provide the parameters like, hey, I want 10,000 users, or I want 100,000 users, or I want 50,000 files of each size 100 gigabytes, and based on that the load test would be able to run. And since it runs in Jenkins, we are able to prevent the issues with network bandwidth, or the resource constraints like, oh, I was running in my local but my machine got shut down, or hey, my network was bad, so today I was trying to run a 5x load test but it turned out to be just a 1x of a load test.
So what does your worker node look like to run this test? I have a feeling it has to be a little bit more beefy than what some laptops are.
Yes. So that's a really good question, Cynthia. So that's one of the advantages of having it in running in cloud or JMeter than your local, is that you can scale either horizontally or vertically, right? So we can have the load test divided into like say 4 parts. If I want to run like say 100,000 files, I can say here is what I can run it in 10 different Jenkins nodes, Jenkins slaves. Each one would be running for say 1,000 or 10,000 of them. Or I can say that, hey, I want to get a big enough node which has like say 100 gigabytes of memory and 1 TB of disk space so that I can run all in one node as such.
So let's wait a little bit to see if anyone else has any follow-up questions to that information. I'm just watching the chat and seeing if anyone else is going to chime in. Yeah, I would have been very surprised if you could have run that on your machine because I'm like, wow, that's some super machines you all got.
Usually running it from a machine as seen like, hey, I'm running it from my work, so I have a LAN connection, so yep, I can transfer data much faster than, oh, I'm running it from my home and have a bad network connection, so I can run my load test but I can't watch Netflix anymore.
Okay, so I don't see anyone else asking questions, so feel free to go ahead.
All right. Uh, Thank you, Ewan, for the helpful demo. It was certainly helped us understand the nitty-gritties of the running the functional automation as part of load test.
And I'll pass the presentation back to Braddy.
So, since we had a quick look at the demo of how one can use the load test using functional automation and what are the different challenges we started with and what is its strategies and what are the, and we had a pretty interesting questions from Mike and Cynthia. Uh, so, in order to summarize, I want to go over what are the different lessons learned by using functional automation as part of our load testing. Uh, one of the one of the important lessons we learned was having a dedicated load test environment helped us run the load test in much more easier and faster manner rather than having a fixed schedule of load tests when one had to coordinate over each different environments over the or each different components and each integration in parts of the organization. One could easily run the load test with having minimum noise uh, as such. And one does not need to worry about, hey, are the resources in same as what I have in prod? Will my environment be able to have the same code base as what I'm expecting as part of a prod as such? Secondly, your load tests are as good as the load profile you determine on. So as we've gone over, you can, if you have a historic data of your application available, that is something which we can use for determining the load profile. In cases where the historical data is not available and it's a new application being brought up, it's often a good question to ask that what are my requirements for my application from a load perspective? Am I supposed to handle X amount of load versus 2x amount of load in order to get a baseline as well as understand the application as well as understand what is the amount of load my application can handle in scenarios where we don't have a fixed requirements regarding the load. It's often good to go with something as a soak test or something to determine what is the failover point when my application starts failing or when I see a degradation in the performance of my application. Additionally, given the dedicated environment and the one-click configuration and integration with Jenkins, we were able to run load tests after every major release as part of the application. This helped us identify any issues with the particular code changes or the integration changes as such. Uh, Earlier, I mentioned about having running a component-based load test versus end-to-end load test. Most of the times running an end-to-end load test frequently after every release is cumbersome, also comes with a huge amount of cost. Divide and conquer approach of load testing, of running it against a particular application or a particular component, helped us running the load test and specific components which have changed over the release as such. This had helped us pinpoint the issues rather than having to spend days and days figuring out where the failure was as such. Additionally, we encountered a lot of idempotency issues which were discovered as part of the load test. This is something as similar to having a producer being able to send data whereas consumer never having received the data. Some of the interesting issues was a producer having sent one packet of data as a consumer receiving 10 packets of data due to uh, due to the internal integrating applications having timeouts or having retrying functionalities, which functionally seems to have worked, but during heavy load was unable to keep up as such. We usually say that, hey, rather than running in on-prem, shifting to cloud is going to give me additional unlimited resources as such. During load tests, interestingly, we saw that we hit a number of issues as part of the cloud-based limits. We saw issues with the KMS keys limit for each account. We were having issues with interacting with the API limits for different applications like S3 as well as RDS, DynamoDB, etc. Additionally, we ran into issues with the different nodes like Lambda limits per each account, EMR limits across a region or account, as well as interestingly, issues with between different applications running using a same set of resources and running into issues with each other as such. We also saw interesting issues with the network limits, such as not having enough subnets for an account, or running or not having enough IP addresses to have new resources populated as part of the application runs as such. We also were able to find some interesting functional issues with the integrating systems, as well as the um, application, which we didn't discover as part of functional testing as such. Some of the examples were like uh, having a retry functionality, which did kind of over retrying rather than retrying once or twice, having a failover which was not failing over successfully under the load, having different implementations like LDAP, or different level of users not able to log in as part of uh, the functional issues as such. Another note we saw is the logging limits. Um, Normally, logging is something which we take for granted, and we normally don't ever envision of having issues with the logging as such. But when we were running applications at in like say 2x or 4x, we saw that we were running into limits with the logs. The logs were in general slow to load, and sometimes we got the limits on the license on the Splunk side, due to which the logs were not able to load at all. This was something which was superb important, given like the issues one can run into prod and not having any logs to know what happened with the application as such. Now that we have advocated with the component load testing and its importance in general, I wanted to go over the end-to-end load testing. What were the different lessons we learned as part of that? Generally, we have seen end-to-end load testing having issues with the having a schedule of all the applications being available, as well as the cost factors of everyone running the load tests in general. For end-to-end load testing, we generally went with two approaches. One being integrated load test, where the starting application is going to be running the load test, and all the integrated systems would be consuming that load. We saw some issues with the load or the data provided not being the enough quality for all the integration systems to be consuming as such, and resulting in issues as such as the load profile for each integrating system being different, that one system providing the data in a particular format or particular requirement was not enough. In those scenarios, we went with simultaneous load tests, which which as by simultaneous load tests, each application would be running their load test individually in concurrently. Henceforth, each application would be having their load tests, which were run as part of the component load test run. Hence, we were able to verify end to end what is the issues one could see from a network point or a resource point when all the applications are running at the same time, as well as identify any issues as such. Last but not the least, having functional automation run as part of the load test helped us make our functional automation thread safe. Normally, when it comes to functional testing and functional automation, we generally run tests in like one test in sequential order. Having this functional automation to be used as part of a load test helped us improve our functional automation to make it thread safe, and have the aspect of thinking of how can my functional automation would be when it runs with multiple threads in general. This helped us improving the throughput of a functional automation and able to run the functional tests in parallel as such. That's all we have from the leveraging how we can leverage your load testing automation for running the load test as such. Any questions?
15 seconds to see if anyone else wants to do anything on the chat. I think that might be it.
All right. Thank you all for attending the presentation. Feel free if you have any questions, or feel free to email us to Cynthia or us, and we will try to get you best answers as we go. Thank you.
So, thank you everyone at FINRA for presenting. Thank you, Ewan. Thank you, Braddy. Thank you. We also have Samir on the line, but he is staying very quiet. But yes, if you have any follow-up questions that you would like to ask, either the presenters or myself about dcast, I think Braddy, you're on Slack.
Yes, I recently joined Slack for dcast.
Okay, so you can reach out to him directly there if you have any follow-up questions. And I guess we will see you all for the next event that we have. So thank you all very much for joining us, and please stay safe. Oh, actually, Michael has one question for you. Michael says, from an integrated load test between multiple systems perspective, can you elaborate on the reasoning behind that?
So, need a bit more context as such. I will try my best to answer from Mike's perspective as such. Uh, Integrated load test or end-to-end load test. Uh, when we run end-to-end load test, we try to see the whole system as such, see like what is the overall load if a system can be handling, rather than a particular component in between. Usually by component based load tests, we assume that you would be able to you will be able to check and certify your application for the load it can handle. But the main strategy of having integrated load test is to see if there are any issues between the integration applications, like hey, an application which is consuming all the resources and none is available for the other application, or when the applications run under load in parallel, do we have any other issues which we can see. So the approach we followed for integrating load test was to have a single team which can run this load test, which all the integration teams can consume. In these scenarios, we were able to verify that all the integrating teams were able to consume all the data and had no issues. But often we saw some drawbacks as such, like the load profile is different for each application as such. Also, the data quality, which may be sufficing for a single application, may not be the quality intended for all the integrating applications as such. In order to overcome this issue with end-to-end load tests, we went with simultaneous load tests, in which each application would be using their own generated or engineered data. With this approach, some of the advantages we see is no application is dependent on other application for the data to run their load tests, whereas sufficing the issues or able to we still be able to see any issues with the resources or any simultaneous execution of the systems in parallel. Does this answer your questions, Mike?
Let's give it a few seconds for him to respond. hoping. I'm hoping that he's not typing like a humongous paragraph. Because I can't see if anyone's typing. Well, I hope that answered his concerns. If anyone else has any other questions that they want to ask the presenters offline, you can either send it to us via Slack or you can email us, and we will do our best to make sure that the presenters get those questions. But other than that, I think it's a wrap. So thank you all so much for coming. Please stay safe, and we'll let you know when the next event is. So thank you all.
Thank you, Cynthia.